Hi everyone. So recently we've been talking a lot about radical expressions, but now we're going to kind of put them into action and solve some equations with radicals in them. So our only objective today is to solve radical equations, and we're going to do a bunch of them. All right, so first a few things we should know. A radical equation is an equation that contains a variable within a radical. So a variable here. And this looks like, something like square root of x equals 3. That's a radical equation. Our variable is within the radical. To solve radical equations, we will end up squaring both sides. So we will square both sides of our equation. All right, let's jump right in and do a bunch of problems. All right, here's our first problem. The square root of x equals 8. And when we solve these problems, we really are just solving for our variable. So we want to solve for x. So right here, we have x in a square root. So to get rid of that, we're going to square both sides. So this side squared and this side squared. What we're going to get is x equals 64. Now sometimes when you solve radical equations, you're going to get answers that are called extraneous, which means that they don't work for our original equation. So it's always very important to check our answer, to plug in what we get back into our equation. So let's plug this 64 in. For x, I'm replacing my x with 64 equals 8. And now is this true? Yes, the square root of 64 is 8. So x equals 64. All right. Number 2, the square root of 2x minus 1 plus 4 equals 7. Now, there are a couple different ways to solve this kind of problem. One of them is to get the thing in the square root alone first. That's the way that I prefer, but I'll show you a different method in a minute. So I'm going to try to get the thing in the square root alone. So to do that, I'm going to have to subtract 4. Notice that square root sign does not extend to the plus 4. So it's outside of our square root. So I'm going to subtract 4 from both sides, and I get the square root of 2x minus 1 equals 3. Now I have this squared thing, this square rooted thing on this side. So I'm going to square both sides to get rid of it. And I get 2x minus 1 equals 9. And now this is just a two-step equation. I'm going to add 1 to both sides. I get 2x equals 10. Divide by 2, and I get x equals 5. Now, it's important to plug it back in to check, so let's do that. We'll rewrite our equation up here with our x as 5. So I have 2 times 5 minus 1 plus 4 equals 7, and we want to find out whether that's true or not. So this is going to be 10 minus 1 plus 4 equals 7. This will be 9, the square root of 9 plus 4 equals 7. Square root of 9 is 3. 3 plus 4 equals 7. And yes, 3 plus 4 equals 7. All right, let's do another one, and I'll show you the different method. Number 3. 3 square root of x equals 21. Now, if I solved this the way that we did last time, I'd try to get the thing in the square root alone. So I divide by 3. But I'm going to try a different method. I'm going to square everything from the get-go. So I'm going to square this side, and I'm going to square this side. And what I'm going to get is 9x, that's 3 root x squared, equals 441. All right, now I just divide by 9 on both sides, and I get x equals 49. Okay, so that's one way to do it. Now let's check our answer and make sure that we're right. So 3 square root of 49 for x. Does this equal 21? Find out. Square root of 49 is 7, so 3 times 7 does indeed equal 21, so we're good. All right, let's do another. All right, number 4. Square root of x over 3 equals 5. You have a couple of options here. You can either solve the way that we just did by squaring both sides first, or you can get the thing in the square root alone. I'm going to get the thing in the square root alone, just because that's my preferred method, but you can do it whatever way you feel most comfortable. All right, so let's multiply by 3, so I can get rid of that 3 in my denominator. So what I do to one side, I have to do to the other. And I get square root of x equals 5 times 3, which is 15. Now I'm going to square both sides to get rid of that square root. And I get x equals 225. All right, let's plug it back in to check. So I'm going to get square root of 225 over 3 equals 5. See what that is? Square root of 225 is 15. So it's 15 over 3 equals 5, and 15 divided by 3 does, in fact, equal 5. So we're good. All right, let's do one more of these, and then we'll explore something slightly different. Number 5 looks a little bit different. So here we have square root of x plus 8 minus square root of 3x equals 0. We have a couple of options here too, but I am going to show you by far the easier method. So here, we could square everything to begin with, but that way we'd have to end up foiling. We have some term minus another term, so we're going to have to FOIL those out. An easier way is to add one of these square roots to the other side, or move it to the other side. So I'm going to do that. I'm going to add the square root of 3x to both sides, and I get square root of x plus 8 equals the square root of 3x. Here's something we haven't seen before, square roots on both sides. Don't freak out, we just have to square it like the last time. So we're going to square both sides, and these square roots will disappear. We'll get x plus 8 equals 3x. Now I just have to solve for x by combining my like terms. So I'm going to subtract x over here, and I get 8 equals 2x, divide by 2, and I get 4 equals x. Now we should check to make sure that this works. So I'm going to plug this back in. I get the square root of 4 plus 8 minus the square root of 3 times 4 equals 0. We'll see if this is true. So square root of 12, that's 8 plus 4, minus the square root of 12, which is 3 times 4, equals 0. We don't know what the square root of 12 is. It's going to be a decimal, but we don't have to, because what we see here is the square root of 12 minus the square root of 12 equals 0. These two cancel, and this does, in fact, equal 0. So we're good. All right, let's look at something a little bit different. Remember earlier when I mentioned extraneous solutions? Here we're going to see one in an actual equation. So sometimes squaring both sides can result in an extraneous solution. An extraneous solution is a solution that does not make our original equation true. So it doesn't work for our original equation. So here in number 6, we have the square root of 6 minus x equals x. So I'm going to square both sides to get rid of that square root, and I get 6 minus x equals x squared. Don't freak out about the squared variable. We're going to make a quadratic equation. So I'm going to move all of this stuff on the left to the right so that I can keep that x squared positive. You can do it the other way too. Makes your life a little bit more difficult though. So I'm going to add x to both sides, and I'm going to subtract 6, and I'll get 0 equals x squared plus x minus 6. Now you know that you have options here. You can use the quadratic formula to solve this, you can use factoring, or you can use completing the square. I'm going to use factoring since I think it's probably the quickest method. So I'm going to factor this into 0 equals x plus 3 times x minus 2. Now here's where I make my little baby equations. So I'm going to bring this guy up here, and I'll have x plus 3 equals 0 and x minus 2 equals 0. I'm going to subtract 3 from both sides here, and I get x equals negative 3. I'm going to add 2 to both sides here, and I get x equals positive 2. So here I have two answers. And this is where it's super important to check your answers to make sure that both of these work. So let's check x equals negative 3 first. X equals negative 3. I'm going to plug it into my original equation here. Square root of 6 minus negative 3 equals negative 3. Let's see if it works. So here I have 6 minus negative 3 is going to be 9. So the square root of 9 equals negative 3. Little question mark here because we're not sure if this is true. Square root of 9 equals 3. Does 3 equal negative 3? No. So this one does not work. X cannot equal negative 3. Let's try x equals 2. So if I have x equals 2, I'm going to plug that into my original equation here. Square root of 6 minus 2 equals 2. 6 minus 2 is 4, so the square root of 4 equals 2. Does it? Yes, the square root of 4 is 2. So 2 does equal 2. And our only solution here, so the takeaway here is that our only solution is x equals 2. It's the only one that works with our original equation. All right, I'm going to set you loose, and you can try those problems at the bottom of your guided notes. Thanks for watching.